Hello, Algebra 2. We're going to continue our series of a bunch of short videos that help you go through and look at some of the new math a little bit at a time. Again, not trying to do too much at once. And then following this video, I'm going to post a Google form. I'm trying to kind of try different ways for you to check your understanding. Delta Math is amazing, but there are certain topics that I don't really feel like it has the best examples. So it looked like from what I'm seeing from the last Google form, you guys were very comfortable entering, and it's usually quick, a lot of multiple choice questions kind of going through this. So when you are watching this or when you're going to do that Google form, make sure you watch this first, and you can always jot down some notes. You can take some screenshots. You can rewatch some pieces so that when you get to that Google form, you feel like you can find the example that helps you the best. So today's lesson is called the number e, which that in of itself sounds very strange. There is a number called e, and I want you to think of it kind of like pi. We use a symbol to represent pi because it is a number that goes on forever and ever. Well, in this case, we use a symbol for this number called e. It's referred to as the natural base. It gets its name a couple ways. It's called the natural base because it's found a lot in formulas that are very scientific, biology-based formulas, nature-based formulas. Also, a lot of finance-based formulas will use this number. The reason the letter E was chosen is the mathematician that actually developed and worked with this number, his last name started with the letter E. His last name was Euler. It's written here on the second line. It doesn't look like it. It looks like Euler. His name was Euler, and because he was the one that did the work with it, and his last name started with an E, he used the letter E. It is an irrational number, meaning that it cannot be written as a fraction. It goes on forever and ever. However, it is still a number, so it should be treated like any other constant. The approximation of E is 2.71828, and then it just keeps going and going and going. I'm going to show you in a second how to do it on your calculator, but I want to start with some things that kind of review what you've already done. So since E is just a number, we can use exponent rules. So when you go to do your Google form later, you're going to see examples very similar to what you see here, just practicing basic exponent rules. So for the first one, for letter A, we have e to the third times e to the fourth. The exponent rule says when you multiply bases, you add the exponents. So you're going to add the 3 and the 4 together. You get e to the seventh. The base stays the same whenever you do exponent rules. If you look at the second one, we have a 10 divided by 5. You should divide those. 10 divided by 5 is 2. But then when it comes to the e's, again, you use your exponent rules. When you divide bases, you're going to subtract exponents. So 3 minus 2 is 1, so you just get e to the first power. C, you end up with power to a power. So first you're going to take 3 to the second power. You can do it on your calculator if you need to. It's just 3 times 3. And then for your exponent rule, you're going to multiply your exponents together. So you're going to multiply negative 4x times 2 to get negative 8x. Yes, dear. And then when you're done with that, you're going to move it because negative exponents belong in the denominator. They're in the wrong place. And so you end up with e to the 8x on the bottom. For D, you're going to take 2 to the third power, so 2 times 2 times 2, which is 8. And then you're going to multiply your exponents together to get 9x. Bottom, you don't have to do anything with it right away. You're then going to reduce the fraction, so 8 divided by 6 reduces to 4 over 3. And then you're going to subtract the exponents. Again, when you divide bases, you subtract exponents. So 9x minus 1x is 8x. And that is your exponent. And again, your base doesn't change. The middle example here, choice E, this one reviews our radical simplifying that we did back in chapter 6. The square root of 81 is 9. If you don't know, if it's a square root you don't know, you can use your calculator. And then when you have a power and a root, you divide. Power is 6x. Your root is 2 because it's a square root. So you're going to take 6x divided by 2, power over root, and that's where you get the 3x exponent. And then finally, F, whenever, your bases are multiplied, you're going to add your exponents. So you're doing this like you're adding like terms. Just like choice A or option A, you added the 3 and the 4. Down here, you're going to add your x's. So you're going to add your 2x and your 3x. That's where the 5x comes from. And then you're going to add your constants. 5 plus a negative 2 is 3. I know this has a little extra mark in it, but this is e to the 5x plus 3. So when you do your Google form, I put like one of each of these. I think I did about 4 examples, so not quite as many, and where you're going to have to use your exponent rule. So now this number E is a number that is a decimal that goes on forever. So there is a button on your calculator to do it. So let me show you where that button is. To get to that E button, you're going to hit the second key. So you're up here, your blue key, and then you're going to hit the button that looks like it has an IN, or it's actually an LN right here. It has a little E up in the upper corner. So you're going to hit that button and it'll pop on your screen, and then you can put any exponent you want. So if you want to know what e to the fourth is, you're going to enter it that way. And you get, again, a decimal that goes on and on forever. There is one that I put on the Google form. I just wanted to make sure you knew where the button is. I did round it to 2 decimal places. For B here, I wanted to know what e to the 0.6 power is. So you do second, and then this button that has the ln on it, and you put 0.6 as the exponent. Again, you get a lot of decimals. If it has other things with it, like this one has a -3/8 first, you're going to type in your -3/8 first, and then you're going to hit your E button. So again, second, and then this LN button here, and type in your exponent, which is 0.5, to get your answer. So anytime you need to find that, this might be something you want to jot down, or maybe take a little screenshot, or just take a look on your calculator. You hit second, you hit this button that says LN right here, the little E will be in the upper corner, and then it'll give you that base E, and you can work with it with any exponent you want, and just expect you're going to get a lot of decimal answers with this. And then finally, the last thing I want to talk about is what the graph looks like of these. So since E is a number, when you take E to a variable power, we're going to have growth and decay situations happen. To figure out whether it's a growth or decay, it really depends just on the exponent. So if you look at something that has an E to a positive exponent power, so E to the 2x, E to the 3x, that is going to be growing. If it had a negative exponent, it's going to be decaying. If you want to check it on your calculator, it's very easy to do the same thing with that E button, and you can take a look at the graph. It is going to grow very, very quickly. This is an exponential growth graph. The first couple lines are what I just said. The R, the number in front of the X, determines if it's going to grow or decay. You can graph it as well to help you. So if you have a positive R, it grows. If it has a negative R, it decays. Your domain, just like all of the ones that we did a couple days ago, your domain is all real numbers. It's going to go forever to the left and forever to the right. The range is going to be everything above the x-axis. So your range is going to be everything with y greater than 0, or you can write it from 0 to infinity. It's all the stuff on the top half of this graph. And then finally, the y-intercept, which is where it crosses the y-axis, is going to be whatever number is in front of E. So if you have a 4 in front of it, it's going to cross at 0, 4. If you have a 6 in front of it, it's going to cross at 0, 6. If you have nothing in front of it, it's going to cross at 0, 1. We do have an asymptote with this graph, a conversation that we had before. An asymptote, again, is a line that it gets really, really close to and never touches. And it happens, again, right along this x-axis. You'll see this graph get really, really, really close to it and then never touch it. So if you look at a couple examples here of some pictures, and I'll show you how to do this on your calculator, if you want to see what 2e to the 0.75x looks like, you grab your calculator. You're going to go to y equals. Get rid of whatever you did before if you have anything. My calculator is kind of empty right now. So I'm going to type in 2, then I'm going to go to that E button, second, and then the ln. And then my exponent is 0.75x. And then you can hit graph. And you will see a graph slowly show up here. Gets really, really close to the x-axis and then goes up very quickly. My calculator is very slow right now. This is obviously a growth graph. It's going up. The other way you can tell that even without the picture is that it has a positive exponent, so we know it's going to grow. My domain is always all real numbers, no matter what the equation is. My range is everything bigger than 0, so you can write it like this, or y greater than 0. And again, my y-intercept is whatever is the coefficient, and in this case it's a 2, so you can see it cross the axis at 2. For this one, this is still a growth because it has a positive exponent. Really, the only difference in this one is your y-intercept. That's actually a 0.5. I think the decimal's really faded. Or you could write it as 0, 1/2. To do this on your calculator, you're going to go to y equals. You're going to get rid of this graph, and you're going to type in 1/2. E, second, and this ln button, 3x. And then hit graph. And again, it will slowly come up and you'll see a picture that's very similar to mine. I'm not going to have you graph anything, but I am going to give you some graphs on the Google form that you have to identify some key features. So all real numbers, again, is always the domain. Everything bigger than 0 is going to be your range. And then your y-intercept is whatever value is in front of your E. So in this case, it's at 1/2 or 0.5 you can write it as. You should be comfortable with, again, the basics. You should be comfortable with exponent rules. So looking at these examples up here, you should be comfortable with your calculator button. And then you should understand understand the basic characteristics of the graph. If you are good with those things, you should have no problem going through and doing the Google form that is out there. It should not take you very long. It's 10 quick questions, and hopefully you are comfortable with. Maybe we'll close this out. Maybe not.
Did you finish?